Hi guys, welcome to video 3 of Surds. We're going to be looking at a different rule to videos 1 and 2. Video 1 we looked at the multiplication and division rule. Video 2 we looked at multiplying a surd by itself. Now we're going to look at what happens if we add surds together. So we already know from video 1 that if I have a surd multiplied by another surd, it's the same as the two numbers multiplied together within the surd, or vice versa. So if I had m times n inside the surd, so 9 times 8, it's the same as the square root of 9 times the square root of 8. What we want to test is it also true if I add two surds or subtract two surds? So I've got two numbers which aren't surds, but they are in square roots, which is the square root of 9 and the square root of 16. I'm going to work them out in both ways, as two separate answers and as one, and see if I get the same value for my answer. If they are the same, then it's true. If they are not the same, then it is not true. Okay, so I know that the square root of 9 is 3. I know that the square root of 16 is 4. So that gives me 7 overall. What happens if I add the two numbers together first? I get the square root of 25, because 9 plus 16 is 25. When I square root my answer, I get 5. So it is not true. This isn't technically a surds rule. It is something that is not true. Unlike multiplication and division, addition and subtraction, you cannot separate the surd or keep the surd together and treat them the same. So what do I actually have to do if I'm given a few surds and I'm asked to add and subtract them? Okay, so I've got the square root of 50 plus the square root of 162. That 2 is not very clear. Okay, so rather than being able to write it as the square root of 50 plus 162, I'm going to have to simplify the surds first before I can add or subtract them. I can only collect together terms which have got the same surd part. So we already know from the last video, if you do root 3 plus root 3, you get 2 root 3. And we also know that if, for example, I had 4 root 5, take away 3 root 5, or 2 root 5, let's change that to, I end up with 2 root 5. Just like with algebra, x plus x is 2x. 4x take away 2x would give me 2x. Okay, so I'm going to have to simplify the square root of 50 first. Well, I know that 50, well, if I list out all the factors of 50, I'm looking for the highest square one. The highest square factor of that would be 25. I'm going to work downwards from root 50. So 25 times root 2. That gives me 5 root 2. I'm going to do the same thing for 162. However, I already have noticed that the surd part is root 2. So I'm going to think about what happens if one of my factors is 2. Does it give me a square number? If I do 162 divided by 2, I get 81. So yes, it does. By noticing what I end up with on the smaller version, or the easier one to simplify, I've spotted that I'm probably going to have a root 2 there somewhere, so I check to see what happens if a factor of 2 is used. So again, write my square number first. Root 81 times 2. So that gives me 9 root 2. Again, I've got 5 lots of something plus 9 lots of something. That gives me 14 root 2. Okay, moving on to my second example, I've got 3 things here. I've got a surd plus a surd minus a surd. I'm going to do the same thing. I can already see that I've got a 3 root 5 and that the root 5 will not be simplified no matter what I do. So what I'm going to try and do is I'm going to try and simplify this and see if a factor of 5 would give me a square number. If I do 320 divided by 5, I get 64. 64 is a square number, it's 8 squared, so I know that this 3 root 5 has given me a good indication as to what to separate this into. Again, I'm going to work downwards for root 320. So I've got root 64 times by 5, which is root 64 times by root 5, which is 8 root 5. I've still got that 3 root 5 that I had all the way throughout. That stays the same. 500, well, I can spot straight away that 100 goes into 500 and it goes in 5 times. So again, I'm going to end up with that root 5, which is perfect. So I've got minus 100 times by 5 minus root 100 times root 5, which is minus 10 root 5. Now all I need to do is put them together. If I've got 3 of something plus 8 of something, that gives me 11 of something. 11 of something, take away 10 of something gives me 1 root 5. Just like with algebra, I wouldn't write it as 1 root 5, I would just write root 5 as my answer. 2 more quick examples to have a go at, and then I've got a couple for you to try. 27, that's a smaller one out of the two, so I'm going to simplify that one first and see what happens before I move on to the 48. So 27 I already know is 9 times 3, so I'm going to simplify that like this, write it as 2 separate surds. That is 3, and that's root 3. For root 48, I'm going to try and see what happens when I do 48 divided by 3 and see if it gives me a square number. Well, 48 divided by 3 is 16, and 16 is a square number, so that's what I'm going to divide it by. That gives me 4 root 3, and if I add those together, I get 7 root 3. Moving on to my next example, I've got the square root of 63 plus the square root of 32 plus the square root of 28 minus the square root of 98. There's a lot of stuff going on there. All of my numbers are fairly low, so I think I'm probably going to just try and work them all out rather than spotting any patterns. Okay, so square root of 63, I know that 63 is 9 times 7. So I work out what I've got. Root 9 is 3, gives me 3 root 7. I don't think 7 goes into 32. If I look at the surd part, that's what I've been doing so far. I've been looking to spot a pattern. I don't think that's going to work for 32. So instead, what I'm going to do is I'm going to think about what square numbers go into 32. Well, 16 goes in, and it goes in twice. So I've got 4 root 2 there. Do the same thing for 28. 28 is 4 times 7. And then finally 98. Well, 98 is 49 times 2. Okay, well I can see here that I've got a few things with root 7 in. So that's 5 root 7. And then I've got a few things with root 2. 4 root 2, take away 7 root 2 is minus 3 root 2. Okay, 2 questions to have a go at. Pause the video and then I'll go through them shortly. Okay, I'm about to go through them. If you haven't finished, please re-pause the video. Okay, the answers to questions 1 and 2 are now there. Please check through them. You'll notice on question 2 that I've done it in 2 ways. The first way, I haven't picked the highest square number, so I've picked 9 times 8. And when I've simplified that, I've got 3 root 2 plus 3 root 8. That can actually be further simplified, which I've done below, but that's taken a lot of steps of working out. If instead, when I'd simplified 72, I had gone for the highest square number, which is 36 as its factor, and simplified, I would have got to 9 root 2 in a lot of a quicker way. Okay, 4 more questions for you to have a go at. Slightly harder than the last 2, just because the numbers are bigger and it might take you a little while longer, but the same concept applies. Please pause the video. These are the final 4 questions of this part of Surds. I will be showing the answers shortly. Okay, the 4 answers are now there for questions 3 to 6. Very, very important point. On each of these, I didn't start simplifying from the surd that is on the left. I always picked the easiest surd there was and then used it to try and spot a pattern. If you look at 48, that's a much easier number to simplify than 243. So I thought about what square factors of 48 there were. I found 16. I simplified it down all the way to get to 4 root 3 before I went back up to 243. Because I know it's likely that it's going to have a root 3 in it, I tried to see what factors of 243 would go with 3, and it's 81 times 3, which is a square number. Same thing over here. I started with 99, which I knew was 9 times 11. Simplified that all the way down to get 3 root 11, and then I thought about what would happen if I did 176 divided by 11, and I got 16. Same thing here, I started with the 80, ended up with 4 root 5, and I knew I was looking for maybe a factor of 5 in both of these, and it gave me 25 and 36 as my other factors. Here I started with 28, then worked backwards to 63 and 112, looking for a 7 as a factor each time. That's it.